Here at Twin Peaks, we see a lot of different fracture sets at different conjugate angles. You can see there's one here, and you can see it's parallel, right? And then you can see there's another here, which is the main one, but you can see it also has parallels. And then there's this conjugate fracture set. And so there's lots of different conjugate fracture sets that are parallel in certain regions of the Twin Peaks area. And what we think is happening in the mineralized zones is that you have this fracture set, which is a little bit larger. You can see in some places that there's some gouge, which indicates substantial movement, more so than we have on these smaller fractures. So you have more substantial movement on this low angle fracture, and we think that essentially it's a conduit. And so when you have the volcanic activity that was occurring over yonder and also over yonder, it created these hydrothermal fluids that are charged with minerals from the melt, from the volcanic melts, that then take this path of least resistance, this conduit, and as the material flows through, it cools and it drops out its solution.
It would have taken a little bit of pressure to get this magma fluid, real viscous, metallic solution.
Well, it's
flow.
mostly water coming from. It's not actually magma or
lava,
volcanic lava, if you will. It's waters that are doing the work, and the waters can permeate through these fractures, and it takes with it in solution minerals. And as the pressure and temperature drops, then it then precipitates the solids.
Mm-hmm. That's interesting. Right along here.
Yep, that flat. It's
so linear and so planar.
Yeah, it's a very shallow dipping, which is actually different from the one that we're seeing at some of the other locations. However, it is on this line, on this trend, but that trend runs about this way. But unfortunately, this is striking perpendicular to that. Strike is perpendicular to dip direction. But this one is interesting because it's on that line, but it's a different structure. It's a different orientation on the structure. However, we are seeing the same degree of mineralization here in this red ore, and it seems to be associated with the quartz. And you can see these casts. How they're cubic. Those are old pyrite casts that have been weathered out. And a good indication of gold mineralization is when you have pyrite that has been leached out. So when we see these casts, it's a good sign of potential mineralization of gold.
Is pyrite leached out by what? Acid rain or heat? Heat.
Mostly hot waters.
Hot water heat. Okay.
Hot water that's coming up with a mesothermal or hydrothermal alteration.
Interesting. And the staircases are along faults in these clefts that you mentioned.
Exactly. And so this main staircasing is on a north-south trend. And it's kind of falling down into the valley, and it would make sense. Those mountains over there are the same granite, but they've been pulled apart, extended, and everything's falling in to the valley that has been created.
Interesting.
And that's very typical.
Mostly gold in
the
earth is old gold.
Yeah.
Billions of years old.
A lot of it is Precambrian.
There's no new gold being made.
Well, there is deep underground.
Yeah.
You know, there's granite plutons that are currently being made. You know, off on Chile, Peru. Down there, you have granitic batholiths that are being formed today.
Is that right?
But they're so deep underground that it's going to take hundreds of millions to billions of years to bring it up to the surface so it can erode so that we can get it.
Yes, we go through the whole process, the whole enchilada. Nice. So you got friends, Doc? Yeah, there's friends in there. Yeah, we're gonna have to show this to the gold diggers in San Diego. You show us the rock here.
Yeah. Oh, yep. Here's some more. Just look wherever you want, right there.
Is it right there? Okay. Yeah, pretty much. Everywhere, veins. Oh yeah, look at that. Holy cow. Woo! This is the biggest one yet. Are you excited about that, Doc? Yes, sir. Yes, sir, Bob. That's it. This is it.
Cool.